All right, I am now on page 785, and we're actually going to take a quick look at Module 16, Lesson 2, which is all about transforming quadratic functions. We've actually done this with linear functions, where it's like translate it up, or make it steeper by changing the slope, or translate it, from side to side, whatever. So you've done this before, but the format's going to look a little different, obviously, because it's a quadratic equation rather than a linear equation. Okay, so bottom line is, so far you've learned that a quadratic equation in standard form is ax squared plus bx plus c. And now we're about to look at it in a different format called vertex format, so that it's a little more obvious from that format what we're doing to the function. Okay? All right, I'm going to actually skip through this explanation and go straight to 787, where it gives you some information to help you understand a vertical translation and what that's going to look like in this particular format. Okay, so the graph of the function f of x is equal to x squared. Remember, like just plain old x squared would be our parent function. Okay, well, if we add a plus k, then that's going to mean we're going to translate this whole entire parabola either up if it's positive or down if it's negative. Okay? All right. So for instance, taking x squared and translating it 2 units up, what would it look like? What I'm going to do is, instead of me plotting it by hand, I think it's going to be faster if I will show you on our calculators, because I can type those equations in and get the calculator to graph them a little bit faster. So just hang on. Let me pull up my calculator. All right. So I'm going to put my parent function in for the first line that I'm going to graph. And then it says make a table of values. Well, we're not going to make the table because we're just going to graph it. X squared plus 2. And we're going to see what that looks like. Okay. Window settings, that's typical. I think that'll be fine. All right, so when I hit graph, the first parabola, the first line is going to be the parent function, and then the second one is going to be our translated function, which is this one right here. Okay. Parent function and new one. If you look really carefully, you can see that it's been translated up 2 units. Okay, it's the same parabola. Okay, it's just they've taken the whole thing and shifted it up. So the vertex now sits at 0, 2 rather than at 0, 0. All right. Okay, and now I am on page 788, and we're going to look at making this translation. Okay, so we're going to plot the parent function, which is, remember, just x squared, and then we're going to plot a new function and show that because it's minus 5, that it's going to translate it down 5 units, the whole parabola. Okay, all right, so clear out all of this. Oh, I actually could have just let this stay because I need the parent function as the first one. And then x squared minus 5 is the second one. Okay. There's the parent, and there's the new one. Okay. And you can see the vertex has dropped down to 0, negative 5. Okay. So when you have a k value that's positive, it's going to shift the entire parabola up. When you have a k value that's negative, it's going to shift the entire k value down. Okay. So far, in these last 2 examples, the only thing that we have fiddled with is the k value. I mean, could I do some, changing of the a value in front of x squared and get it to be a stretch and a compression as well as a translation? Yes, and we'll get to those. But right now we're just seeing one at a time what happens when we change one particular thing. Right now we're changing the k value, translating it up or down. Previously we looked at sort of stretching and shrinking by changing the number that sits in front of the x squared. Remember, when it was a big number, greater than 1, it stretched it, made the parabola kind of longer and skinnier. When it was a decimal, it made it kind of squishy and squished and flatter, or whatever you want to say. Okay? Love the technical terms. All right, so now we're going to do another translation, but this time we're going to look at translating the parent function to the left or to the right. I am now looking at page 790, and it's now talking about a horizontal translation of a parabola. And that would be a shift of the parabola to the left or the right with no change in the shape of the parabola. Okay, so now take a careful look at how they're writing it. F of x is equal to x minus h squared. Okay? The graph, the parent function, if we're going to translate it horizontally, we're going to have to shift it to the left or the right h units. And pay careful attention to the fact that x minus h is in the parentheses and the squared is outside, okay, because it's telling you shift it to the left or the right, okay, by doing that. All right, so let's look. Probably an example is worth 1,000 words. And again, we're going to graph the parent function, and then we're going to graph this new function. So here we go. Parent function, so I'm just going to clear this second one out, and we're going to put this in for the second function. So parentheses, x minus 1, close your parentheses, squared. Okay. All right, hit graph. There's your parent function, and there's your new function. And it shifted it to the right. Okay. I want to make sure that you guys understand something important. In the formula right here, there is a negative sign. So if I put a positive h in here, it's going to wind up saying x minus that number. Okay? So x minus a positive 1. I put a positive 1 in there, okay, which shifts it to the right. If I had done x plus 1 squared, then it actually will shift it to the left, okay? So clear. Let's go back, and we've got shifting it to the right, and it looks like it's negative when it's shifted to the right, but that's because that negative was already in the formula. Let's do x minus a negative 1, so x plus 1 squared. And hit graph, and there's the third one. Okay, so it shifted it this time to the left. All right, I am now looking at page 793, and they have now given you the official vertex form of a quadratic function. G of x is equal to a x minus h squared plus k. All right, where you can look at h and k and immediately know the vertex, okay? Here, remember, that is a positive h because the negative sign is part of the formula, okay? So if it still says negative, that's because you put a positive h in there, okay? So h comma k is the vertex of your parabola, and the axis of symmetry is equal to the vertical line x equals h. So the vertex form of a quadratic function can be advantageous because you can immediately see what the vertex is and the axis of symmetry, okay? And now we can do a variety of transformations all at once. Remember, if a is greater than 1, then that's going to be a stretch If a is a decimal, it's going to be a shrink. And remember that if a is negative, it's going to turn the whole parabola upside down, and it's going to point and open down rather than up. Okay? And just remember, we just learned these two guys. If you have a k out here, that's going to tell you shift it up or down. So if it says plus k, you're shifting up. If it says minus k, you're shifting the parabola down. Here, and this is the tricky part, if it says x minus h, then that means you put in a positive number for h and it's shifting to the right. If it winds up saying x plus h, that's because it was originally minus a negative. And so you're shifting it to the left. So you just kind of have to keep all of that straight. But here we go. If we look at this, I can immediately see, here, let me enlarge that just a little bit. I can immediately see that number one, the parabola is going to open down rather than up. Okay. It is going to be stretched because a, the absolute value of a is greater than 1. Here, it started out with x minus h, so I must have put in a -1 to turn that to a positive sign. Okay. A -1 for h means that I have shifted this parabola to the left 1 unit, and then out here my k says that I have shifted the parabola down 2 units. So it's been shifted down 2 units, to the left 1 unit. The parabola is going to open down because of the negative sign, and it's going to be a stretch. So let's see if we can make sense of all of that all at once. I'm going to go ahead and go back to, oh, it's turned off. Clear all this out. I'm going to go back, keep my parent function. And I tell you what, I'll even show you what the parent function looks like if it's written in vertex form. So hang on and I'll just write that out to the side. Okay, so what I'm going to do is I'm actually going to clear all this because I'll write the parent function for the first one, but I'm going to go ahead and write it in vertex form just to get you guys used to looking at that. X minus 0 squared plus 0. Okay. So there's still a 1 for the a in front of it, so it's not a stretch or a shrink. And it's not shifted to the left or right or up or down. So this, in other words, is your parent function. It's not in standard form anymore. Okay. Now I'm going to take and transform it. Remember, I'm going to turn it upside down, I'm going to stretch it, I'm going to shift it to the left 1 and down 2. That's kind of a mouthful. All right. -3 x plus 1 squared minus 2. I think my window settings are still okay. When we hit graph, remember the parent function will be graphed first and then the translated function. There's parent, and there is the new one. Notice it's been shifted down 2 and over 1, and it's been stretched. It's skinnier, and it's opening down because of that negative sign. Okay? Okay, and because it's in vertex form, we can easily see what the vertex is. The vertex, remember, is the point where the parabola makes its turn, so right there. The vertex is h comma k. So because this became a positive, I obviously had to put a -1 in there, so that's my h. -2 is my k, so the vertex is at -1, -2, which that looks right, okay? And then my axis of symmetry is the vertical line that equals my h. So x is equal to -1. My axis of symmetry is right through there.